Hello everyone, I am Mantra Trambadia aka Mantra 7 and I gave yesterday's Codeforces round, educational round 129, and I was able to solve problem A, B, C and D. So I would like to discuss the solutions and the editorials for them in this video. So let's get into it. First, problem A. The problem is game with cards, and I hope you already read it and have tried the problem. I'll just go through the statement briefly. So basically, Alice and Bob are playing a game, and Alice has N cards with number A1, A2, A3 till AN, and Bob has M cards with B1, B2, B3 till BM. And the game is simple. One player puts a card, let's say number on it is X, then another player has to put a card with number more than X. If he can't put, then he loses, and the first player wins. So game can go like X, X plus 4, X plus 7, and then let's say Bob doesn't have any card with more than X plus 7, so Alice wins. And we were asked the task to find out that if both Alice and Bob play optimally, then who will win if Alice is the first player and who will win when the Bob is first player. So one thing to realize is, let's say Bob's greatest card is 38 and my greatest card is less than 38. For example, it's 36. Then is there any way that I can win? So let's say I put some card, then Bob on the first turn itself can put 38 and I'm gone, right? I can't put any more. So if Bob has a card which is higher than all my cards, then there is no way for me to win. And if Bob is the first player, then Bob will put that card first. And again, I can't put anything above that. So similarly, if I have some card which is higher than all of Bob's card, then in my first turn I can put it, or when Bob's first turn is, I can put it as my first card. So Bob put some card, then I'll put that card, and Bob can't put anything above that because he don't have anything higher. So we are only supposed to check the maximum card in both of them. We don't care about all other cards. And what will be the case when Alice's first turn? Alice will win, but Bob's first turn Bob will win. So this will happen when the highest card is same for both of them. For example, if both of them have same highest card, as in this example, 50 and 2550, what happens if Alice's first turn is there? Alice will put 50. And Bob can't put anything over that because you are only supposed to put strictly greater than, not greater than equal to. So Bob can't do anything, Bob loses. But when Bob's first turn is there, Bob will put the same card, the highest card. And now Alice can't put anything because it's not greater than any this 50. So in that case, Bob will win. So I hope you got the logic. So the code is pretty simple for this. I'll just open the code. Yeah. So first, I'm just taking the input and array for Alice, array for Bob, and I'm sorting both the arrays. So a n minus 1, b n minus 1 contains the max card. And if Alice's final biggest card is greater than or equal to Bob's biggest card, it means that when Alice's first turn is there, Alice will win, right? She'll put the card, and Bob doesn't have any card which is higher than that. So that's why I print Alice. But if Alice's final card is smaller than Bob's final, Alice's max card is smaller than Bob's max card, then whatever Alice plays, Bob will play the max card, and it's over. So Bob will win. But in the case when Bob's first turn is there, we just have to take the reverse of it. If Bob's max card is greater than or equal to Alice's max card, then Bob will play that card in the first turn and Alice can't do anything. So Bob will win. But if Bob's max card is less than Alice's max card, then in the first turn of Bob, whatever card he plays, Alice will play her max card and Alice will win. So that's why you print Alice. So this case is when Alice's first turn is there, and this is when Bob's first turn is there. So I hope you got the solution for this. And now I'll move on to the problem B. Okay. So this is problem B. Again, it is related to card, and name of this problem is card trick. The statement is that we are given a deck of cards and cards are ordered from So I'll just draw here. So currently I'm representing card as 1, 2, 3 rather than A1, A2, A3, but you can imagine that it is still A1, A2, A3. 1, 2, 3 till n. This is the order of cards initially. And the question is that uh, we are asked to shuffle the deck m times. And the shuffling happens in a specific manner. So shuffling happens in this way that we select some top cards. In this example, I chose till 3. And after shuffling, deck will become 4 to n will stay as it is. And this 1, 2, 3 will just append here. So this way the shuffling is happening, and we are shuffling m times. Each times we are shuffling top bj cards. So in this example that I showed, top 3 cards were shuffled, and we are supposed to find out that what is the top card after all this shuffling has happened. So let's try to track the top card and see where it is going. So top card is 1 here, right? And uh, after first shuffle, we are removing 3 things from here, moving at the back. So the if the index of top card was 1 initially, now the index will shift by 3 and will become 1 plus 3, right? Because 3 cards have moved. So now the top card is indexed 4. But what if I move n minus 1 cards from 4? So if I move top n minus 1 cards till 2, this, then after this shuffle, the deck will become 3 and this will be appended here. So 4 till n and then 1, 2. So now the top card will be 4 plus n minus 1, but it all is modded by n. And you can understand this more nicely if you imagine this as cyclically shifting the array, because that is basically what's happening. So if it is 1 2 3 4 n, and when you shift the 1 2 3 back, so it is basically a cyclic shift of the array by 3, right? 1 2 3 shifted to back, and here it's cyclic shift by n minus 1. And why we can do mod n thing is because cyclic shift by n is just no shifting at all. So that's why we can easily track what the top card is at each iteration by just doing the index of top card before plus b of j, which is the shift, and take it mod n, and this will be the index after the shifting or after the shuffle. So uh, so it is this easy to track where the top card is at after each shuffling, and the coding will be very simple. I'll just show you the code. Yeah, so the code is I'm just taking the array, and now I'm defining top to be 0 because initial index of top card is 0, and now I'm taking all the BEIs which are shuffling, what is the shifting cyclic shift. So I'll take the cyclic shift and I just update top to be top plus that shift mod n, because top card will move by exactly that places as this is cyclic shift. And at the end, I just have to print the array of top because top is storing the index of the card which is at top. Uh, so okay, I'll now move on to the problem C. Yeah, so problem C is double short, and here we are given two arrays A and B and both has size n, and we can do one specific type of operation which is uh, swap AI with BJ and BI with BJ. So if I just show it here, yeah. So if this is our A array and this is our B array, then we can choose a specific index I and a specific index j, and shift both element of array A and J. So basically swapping of Bi with Bj, Ai with Aj. So this is what one operation is. And we can do at max 10 raised to 4 operation. And our goal is to make both of them sorted in non-decreasing order. And we are supposed to print the sequence as well. So one thing you had to notice in this question was the constraint. So n is at max 100. So if you do the simple brute force way where you check if the zeroth element in both array is at correct location. If it is correct location, then fine. If it is not, then what we can do is look through each index from 1 to n minus 1 and check if any of them fit at zero position. And because AI and BJ are shifted simultaneously, we can just check if AI and BI uh, fit at the sorted position in the index 0. So for this, what you can do is make an array C which stores sorted array A, D which stores sorted array D, and for index 0, we just have to check if any of AI is equal to C0 and BI is equal to D0. If this is happening, then we'll just bring it to position 0 and position 0 is done, right? And after this, we can again go through the array. Same thing, if AI is equal to C1 and BI is equal to D1, then we can bring that to position 1 and we are done. But condition here should be I greater than equal to 0. Here I should be greater than equal to 1 because 0 is fixed, so we can't change 0 now. So we can do this brute force way, and uh, for each index we are doing only one swap, right? So like for 0 case, I'm just doing only one swap to set 0. So at max this will take only n swaps, which is completely fine because n is limited by 100. So it even can take n, we can even do a solution with n square swaps, but this will only take n swaps. So this was just a brute force way. I'll just show you the code so you can understand it more. Yeah, system test was going on. That's why they were in queue. Let me just refresh. Yep. So I'm taking the input A and storing it in C and then sorting the C. Similar with B and D. And now I'm making a vector of pair moves which stores my moves. So I'll go through each index from 0 to n and check if it is already at correct position. Correct position means that AI is equal to CI and BI is equal to DI because C and D stores the correct positions, right? So if it is the case, then I'll just go to the next index. Otherwise, I'll have to check from all j I plus 1 and less than n if any of them have the correct value for Ci and Di. Because Ci and Di are the correct positions. Index, current index should store value Ci and Di in the sorted array. So for example, index 3, I need value of array A to be C3, value um, of array B to be D3. This is array B, this is array A. So for to do this, I must have somewhere in the later element some index j for which it is currently C3 D3. If I find this, then I'll just swap it here. Uh, let's say this was some random thing xy and not the correct one. Then if I found the C3 and D3, then I'll swap it with here so that it is becoming correct C3 D3 and this will become xy. But we don't care about this index yet. We are uh, filling from left to right. So for that, if a of j is equal to ci and b of j is equal to di, then we found our pair. So for that, I'll just set flag to be true. flag just stores if I found any pair or not. So if I didn't find any pair, then flag will be false. So if flag is false, then I just see out -1 and return. Otherwise, I'll whenever I find a pair, I just uh, push that pair in my vector. I, j is pushed, and I'll swap ai aj, swap bi bj. So after which it will check for next index. Again, it will go through the all the array, figure out if there is some pair which goes there. If it goes there, then it will move. So at max, this will do in n moves, and this is basically brute forcing, figuring out for each pair if any other pair fits or not. And we can do this because n is limited. So n square works because n is only till 100. So after that, at the end, I just print the size of moves, and for each I in moves, I'll print I dot ff plus 1 and I dot ss plus 1. FFSS are just first and second, and plus 1 because my indexes is from 0, but the answer indexing is from 1, so I just do plus 1. So yeah, some people took time to do this because they didn't realize brute force and they tried to figure out efficient solution. But you always keep an eye on constraint. If you can do this solution, then you should do this fast and move on to the next problem. So yeah, I'll move on to the problem D now. So this is problem D, required length, and here we are given two integers n and x, and our goal is to make size of x, length of x to be equal to n, and we can do one operation to do this. Go through x, choose any digit y of x, and change x to be x times y. So first thing that you should notice is 0 and 1 are not at all useful. So if x has 0 or 1, we should never multiply by it. And because n is always from 2 to 19, so we never have to decrease x to 0, so that's why we'll never multiply with 0, and multiplying with 1 doesn't do anything, so we won't do that as well. So all the options that we have is 2, 3, 4, 5, 6, 7, 8, and 9, and our goal is to make the length of x to be n. And another thing to notice is max value of n is 19, so that will be handy. So at max, we want to make x to be 10 raised to 19 minus 1. So all the x larger than this, if we can make, we don't care about them because we only need 19 length. So one thing that you should think at this point is, does brute force work? So again, from the previous question, similar manner, does brute force work? But how do you check in this one? The checking is a bit difficult. And one nice fact for that is, at each iteration, you can only multiply x by one of these things, right? So we have one advantage on our side, that we know all the numbers that we can generate will have some this form, where x is 2 raised to a times 3 raised to b times, now realize the fact that you don't need to do 4 raised to c because 4 is covered in 2, and similarly 6 will be covered in 2, 3, 8, and 9. So we just care about the prime factor, so I'll just do 5 raised to c and 7 raised to d. So all the number capital X that I can generate from x will be of this form. And how many numbers are there of this form that are less than our this number 10 raised to 19 minus 1, because we don't care about more than that. So let's check what is 2 raised to a equal to 10 raised to 19 minus 1, then what is value of a? So I'll just open Python. It's easier to check this way, so I'll just set uh, LG to be log of 1 in 19, and so I'll print LG by log of 2, which will basically mean log base 2 and uh, value 1 in 19. So this is 63 points, so I'll just take 64 for now. So A is less than 64 for sure. Similarly, if I do LG by log of 3, then I'll get the max value of B. And B is less than 40. Similarly, let me try to get value of C. LG by log. Okay. LG by log 5. Uh, so C is less than 28. And what is the value of D? LG by log of 7. So D is less than 23. So these are the individual max values of A, B, C, and D that we can generate from X. What is the number of uh, integers that you can generate from X in like what is the maximum number of integers that you can generate from X? Because this is not guaranteed that you can always multiply by 2, 3, 5, 7. It should have a digit 2, 3, 5, 7 or their multiple to multiply, right? This is like the worst case. What are all the possible strings that you might be able to generate from X? So, so in this case, A has 64 options, B has 40 options, C has 28 options, D has 23 options. So what are the options that A has? A can be 0 or 1 or 2 till 63. So again, B has from 0 to 39. So these are all the possibilities that A, B, C, and D can make. So all the numbers that you can make of this form are just A times B times C times D. So I'll just do that. 64 times 40 times 28 times 23. And this is 1648640. So 1, 2, 3, 4, 5, 6. So it's uh, 1 is 6 of the order 1 is 6, right? And 1 is 6, if you know about time complexities, 1 is 6 is doable in uh, like you can do till 1 is 8 in 1 second. So you can definitely do 1 is 6 operations. But this is even the like worst case. In our normal case, when you do brute force, we'll will get only the strings that are really generatable by X. So it will be even less than 1 is 6, because in this case we considered all the strings. And for example, 2 raised to 63 times 3 raised to 39 will definitely be of the order of 10 raised to 38 something, because both are of the order 10 raised to 19. So even this is considered in this case. But when we solve, as soon as we find a string of length 19, we'll just stop, right? So this will be even less than 1 is 6. uh, Around 1 is 5 or something it should be. So let's just do the brute force approach and it will work. So I'll just show you the code for it. Let me just refresh, as this was in system testing. Yeah. So while brute forcing, one thing you have to take care of is store in set all the possible. Don't store in vector, otherwise there will be a lot of repetition. So yeah, start, I'll just take n as a input, the integer, and x as a string. I'm taking it as a string because it's easier to check for the characters in a string than like digits in a number. So first I'll check if it is already of size n, then I just see out n, see out 0, because we don't have to do anything. And if its size is greater than n, which they haven't given the in the case, but I still just checked, then I have to see out -1. Or as I told you, 0 and 1 are of no use to us. So if it is just 1 and 0, we'll just uh, print -1, because 0 and 1 can't increase the length. So that's why I'm checking. I'm figuring out what is the max element in all of x. All of x is just x dot begin to x dot end, and max element will figure out the max from there. So if the max is 1, then I see out -1. Max can't be 0 because number should have at least something in it. It can't be 0. So that's why just checking 1 is sufficient. If it is 1, then I just see out -1 and it's done. Else I'll just make an answer variable which stores all the the number of multiplications that I had to do, and a pos which set of strings which stores all the possible strings after each iteration. So initially possible strings are just x because we are starting with x, and then this is basically a BFS. You can think of it as a BFS. And for this BFS, what I'll do is I'll make another set of string npos, which you can read as new possible. And for this, all the string that are in the pos, so all the strings that are in the pos, yeah, let me just make some empty space. So if pos has 1 2 3 4 0 2 and so on, so uh, at ith iteration we have this many strings possible. Then in jth iteration I'll go to 1 2 3 times 1. I won't multiply with 1 because we realize that 1 do nothing. So 1 2 3 times 2, it will be 6 4 2. 1 2 3 times 3, it will be 3 6 9. Then 402 times 2, 804. 402 times 4, 1608. So I'll do this process. I'll store all of them in npos, and at the end I'll set pos equal to npos so that this process repeats again. So that is what I'm doing. Uh, for each I in pos, I'll just check if any of them has size n. If it is size n, then I'll make flag false and break. So flag was just a variable that was running BFS continuously. And as soon as flag is false, BFS will stop and will get to answer. So if I found an answer, I'll just break out of this for loop, and this also won't execute because flag is false, so I won't unnecessarily increase answer by 1. And this is the part where I store all the characters that are in S. So uh, uh, the way I am multiplying the digits 1 2 3 is I'm making a set to store what digits are there in this string, and then I multiply with all the digits that are there in the set. So I'll just store as close into j minus 0 because we are storing integers here and not the characters. So for each j in I, I'll just iterate to the string and store them in set. And at the end, I'll erase 0 and 1 because we don't care about 0 and 1. And now I just figure out all the possible strings that I can make from given string I, and that will be basically multiplying all the things that are in S with I, and that will be our new string. So for that, I'm making a string ni, which you can read as new I, and this is basically stall of I. Stall of I is string to long of I, which will convert the string I to a long, which has the same value. I multiply it with j, which is the digit in it, and then I convert it to string back again with toString function, and then I insert ni to npos. So now it is a new possible. So in the next round, this will be used. So I just insert it into npos. And at the end, if flag is false, if flag is true, which means we still didn't find the answer, then I increase iterations by 1 because we have done one more iteration, and I set pos equal to npos because in next round we have got new possibilities, not the old possibilities. So now it will do this again and do the BFS next iteration. So as soon as it finds, it will break out and we'll get our answer as answer. And uh, like the crucial thing here was to realize that this will work, and for that you had to figure out what is the worst case that can happen, and worst case was 1a6, that too with considering like the cases that are not even possible. So yeah, so brute force also works here. So C and D both brute force works. So if you find out brute force faster, then you would have done it easily. But otherwise, if you think about optimal solutions, then it would have taken time. So yeah, this was it for this video. I hope you liked this video. Do like, share, and subscribe. Thank you.